Okay, well, good news. Just a couple of minutes ago, I was just kind of straightening up my bench a little bit, wondering about the next steps with this radio, and I noticed, hey, this tube is still on my bench. It's not in. It's the 6BE6 converter mixer tube, and guess what's not going to work if that tube's not in there? The AM band. So as usual, I'm the fault. Hey, so I think we're going to test it again right away and see what we get. Okay, so this is switched on, volume low, and it's in the AM position. And this jumper is simply jumping up. Let's stick it out here. It's just jumping the AM and FM antenna, so both AM and FM are hooked up in a somewhat casual way to the outdoor antenna. Okay, so I think we're ready to go. I think everything is safe. Quiet on the set. Here we go. See the bulb glowing there, about 70% power. Now last time this worked on FM with about that much power. It's dropped a little bit now. Flowing plate currents, that's way down, isn't it? You know what, I doubt it would work, but let's give it a try. Well, you know what I can do? I can keep the restriction on. I'll put the other bulb in. There we are. That's drawing quite a chunk of power, you know. That doesn't look right. That doesn't look right to me at all. See, we're only up to 70%. There's nothing here that should be drawing that kind of power. Okay, man, my nerves are on big time here. Oh, it's doing something. Makes me feel a little better. Let's switch over to FM.
Your budget and make your home shine. But hurry, this offer ends Wednesday, November 27th. More saving, more. That's the power of the Home Depot.
You need to do something.
Take your career to the next level.
Yorkville University is offering an exciting bachelor.
I got 95 copyright infringements just now. Well, we're still running really low voltage here, so I can't expect this to work all that well. That'd be dumb. I shouldn't even bother tuning it around like that. So, a couple things here, and here's the magic eye. Doesn't seem to be any magic in the magic eye. Now, let's... too egregious is going on here, I want to check a couple things. First one is, what's our B plus at this point? We're on FM. 63 volts. That's all. 63 volts. It's really pulled down. I'm floored anything works at 63 volts. 159 on this side. It's only warm. 63. 159. Yeah, so you're dropping 65 volts across that. But then I think if we switch over to, let's say, phono, I think we find all these voltages jump up. No, they don't jump up that much. 181. 180. Oh yeah, look at that. 180. 179. So pretty clear that there's, I would say anyway at this point, there's something amiss still in the high voltage circuits of this set. And we better track it down. It's probably, guess what, a shorted capacitor. Now, I gotta get myself a schematic because apparently I misplaced the one I had. For the life of me, I can't find it. So I'm gonna go print another schematic and we'll hunt down the problem here. Okay, so I got a copy of the schematic here, and I've colored out the high voltage circuits. And what I'm looking for are places where a potential component failure, capacitor in particular, can put a ground on one of these red lines, and that would pull the whole power supply down, be responsible for some of the effects that we're seeing. So now there's four outputs from the power supply: 270, 245, 160, and 150. The 270 and the 245 are only involved in the output stage. And the 170 is applied to the plates of the two tubes that are in push-pull through this center tap transformer. And the 245 is applied to the screen grids. The rest of the set is running on much lower voltage, 160 and 150 volts. So if we trace the 160, here's the 160 here. You know, I didn't look at the schematic very carefully enough to see if there isn't more 160s and 150s and other voltages. So as I say this, I'm scanning the diagram again and looking for more of these, and I don't see any. So okay, we'll carry on then. So here the 160 is going through the push buttons, and this is one of the reasons why the radio behaves so differently. If it's on auxiliary or phono, then the B plus is not applied to this line here, or to this line. But if you push the FM or the AM button, either one will connect. Oh, here's another line I didn't color. Ooh, I missed one. Wait a sec. But that's not high voltage, is it? Yes. There's a whole bunch more high voltage here I missed. Okay, but we won't worry about that. When you push AM, this line comes live, all the way up here, up through this can, the coil, back down to the plate. And also there's a little tap shown here, going to the screen grid and some other grid, because this is a pentagrid. too. It's got lots of grids in it. And look, there's a capacitor right there. That capacitor was short. If it were shorted, it would pull this line to 0, and this is a 1000 ohm resistor here, which would then receive the full 160 or whatever is left of it, because it's going to pull the voltage down right from the supply. So that's a possible one. Similarly, up this way, here's another one. These are just what you might want to call signal grounds. They're capacitors to ground out the signal. Make sure there's no signal on this line. And this one also could ground out, and there's a 1000 ohm resistor. Same deal, actually. Now, did I point this out already? Back on these ones, there's just nothing on there that, if it's shorted out, would introduce a ground in here. We know the audio section's working. And the same thing here. The high voltage, 150 volts, not even all that high, it just goes a short distance and it encounters large resistors. This is a 220K, and that's a 220K, so, and what's beyond it anyway? I don't, well, eventually there is a ground past this capacitor, but big resistors here, so there's no way that this is going to pull down any voltage no matter what happens in there. So we're really back to these two capacitors and this other uncolored line. Let's follow the uncolored line. It comes out here. Here is the top one. Okay, heads up here. It's 1000 ohms this way, and 1000 ohms that way. Not sure why they've drawn that symbol quite that way there. It's a little unusual, isn't it, how they've shown the capacitor there. There's a can here of some sort, or something going on here. So carries on, goes up here through a coil, reaches looks like a plate in a dual triode tube. Goes up this way, small resistor here. There's a capacitor to ground. But you're pulling it through this resistor and this resistor. And we know the FM oscillator is working. This is the FM oscillator. We know it works because the radio works. That's pretty interesting, isn't it? The only thing that's not working really is the AM side. So if we take that as a strong message, it's these two capacitors we need to check. That one and that one. And it looks pretty easy to do, really. You can find either the 1000 ohms or the looks like pin number 4. No. Pin number 6, I think. On the 6BE6. You just get the ohm meter on there. Let's go. Let's do it. Let's do it. Okay, where is that? Okay, so we'll try to find pin 6 of the 6BE6. The 6BE6 is this one right here. And that looks like pin 1, 2, 3, 4, 5, 6. That looks like pin 6 right in there. To ground, pin 6. No doubt about it, I gotta sharpen up my meter probes here there. Wow, that certainly is not a short circuit there. Okay, so that he wins. Assuming that was really pin 6. So let's give a shot at this other one. The other one can be picked up on pin 6 of the AM IF amp 6BA6. The 6BA6. And where's the 6BA6? Yeah, right. I think I see it. 6BA6, there's one there. Looks like another one here. Is there more than one? 6BA6, 6AU, 6AL, 6BE, 6AV. No, that's the only one. Okay, so just a lucky break. I just am able to read it easily on this tube. A lucky, lucky break. And that's this guy. No. This guy here. Who knows how careful I am at identifying tubes from top to bottom, because I found it's easy to boob that up. So pin number 1, 2, 3, 4, 5, 6. Number 6. Look at that. It's as open as they're ever going to get. Okay, what happened there? Oh, it's a totally different circuit. Yeah. Really high impedance circuits, just as they should be. So I think we're out of luck on those. Now we got to go back to what there are some pretty big resistors like that one there in here. So it could be that even a shorted capacitor behind some resistors, if you like, beyond some resistors, could still generate an unexpected current flow sufficient to make a big voltage drop on this guy. Well, let's see. If we look at the circuit diagram here, I'm pretty quiet, aren't I? That's what happens when you start studying these things. Maybe I'll study off camera here for a little bit and see what I can come up with, because my first shot looks like a fail. Okay, so I gave a little more thought, studied the schematic a little bit, and then my eye caught this chart. And that's a chart of the pin resistances. I thought, hey, let's just check a few resistances. Let's see how they work against this chart. And I'm going to pick the same 6BA6 that I was a little bit suspicious of to start with. And I'm looking at the teeny tiny chart. Pin 1. Measured in AM position. Okay, I think we're okay. If we get some funny readings, then we'll look at the specifics of how the test should be done. We'll do that in more detail. So pin number 1, and we get 3.6K, and it should be 3.6K. Pin 2. Pin 2, it should be 0. Well, I can see it's 0. Pin 3. It'd be a very low resistance. 0.4. I get 0.9. That's good. Pin 4 is a 0. Apparently 9 is the new 0. Pin 5. I think it says 0.6. Yeah, okay. Pin 6 is 4500. Ooh. Ding, 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 ding. Pin 6. 4500. Yeah. Pin 1. What do you mean pin 1? Pin 7. Pin 7. It should be 475K. Ooh. Okay, have I lost count? I probably lost count because that looks like pin. Yeah. Oh. Yeah, okay, doing everything right except I'm reading the wrong line. I'm reading the values for a different tube. So, okay. That's... Oh, I just started doing that. So pin 5. Let's go back to pin 5. I made it most of the way. 1, 2, 3, 4. So this is pin 5. And pin 5 from the 6BA6. Pin 5 should be 4,500 ohms. See, now that's not quite right, is it? And that's definitely pin 5. 1, 2, 3, 4, 5. Okay. Now, pin 6, make sure I'm reading the right tube. Same reading. It is the same reading. Same wrong reading. Pin 7, 68 ohms. Pin 7. What is that? Is that 900 or something? I had to change the scale on my meter to read it. 68. I'd say it says 68. And it's reading, 90. So it's the 5. Pin 5. 7, 6, 5. 7, 6, 5. 1.1K and falling. Falling to, look, it's going to 1,000, right around 1,000. It's still going. Just let that keep going. So pin 5 of the 6BA6. You know what, the schematics on, this is the way things go, the schematics on 2 pages. So usually you find this, when the schematics are done like this, they overlap. And the same, along the border between the 2 pages, you'll find the same thing on each page, and you can actually kind of trim it and overlap it and tape it, and there you are. You can see everything wonderfully. This one, there's actually a strip missing. There's a tiny strip missing right up the middle of the schematic, right through the 6BA6 tube, obliterating the part of the tube diagram. Well, wouldn't you know it? So what are we getting down to here? 600 and going down. I'd say we're heading for like 550 ohms. Okay, so here's what I'm talking about here. Okay. So the 6BA6 is this tube, and there's actually a sliver missing right in here. Not this whole gap, a sliver. This is actually much closer to here. So what is pin 5 doing in here? Pin 5. Pretty sure that says 3, 4, 6. Missing. Okay. BA6. What is pin 5 doing? Pin 5 is the plate. Pin 5 is the plate on the 6BA6. So pin 5 is this guy here. Down through this coil and capacitor, IF transformer if you like, down through the other one. Okay, so this is the FM1, this is the AM1. Down at this point, it branches over to the screen. The screen gets the very same voltage, and a signal ground is placed there. Now I tested this. I tell you, I tested it. Now I'm reading to ground, so to get the ground under normal conditions you have to pass through this 1000 ohm resistor, and then we were down to 500 ohms. You'd have to pass through the 1000 ohm resistor, and if there was a ground bolted right on here, you'd still see 1000 ohms. What's going on? Maybe a defective tube, I doubt that very much. There it is. 6BA6. Boy, that's easy to read. Stromberg, Carlson, made in USA. My sleepy meter. Why is it doing that? There's a little bit of a voltage on here. Just like 1/10 of a volt. I mean, my resistance measurement is kind of bogus. Let's open circuit that line. Okay, so that opens this switch right there, and certainly reduces the amount of circuitry that I'm testing when I do this. Hey, it's gone right to 0. Perhaps there's a ground going on to it. I don't see that on the diagram. I don't see that the switch is applying a ground when the AM is off. It looks like it's just hanging out there. Let's put on the FM and repeat that measurement. It's getting kind of interesting. Oh, maybe I booped that up. I had it on the volt scale. So, I don't know what to make of that. 250 ohms. going up. Let's see if we can find that 1000 ohm resistor. Comes off the plate, goes straight through coil, straight through another coil, and then encounters the resistor. So comes off the plate, goes straight through the coil, and straight through that coil, I think. And there's all kinds of 1000 ohm resistors here. 1, 2, 3. How does that work? Supposed to come off, go down through the one set of coils, then right to the other set. Just a wire, right over to the other one. But when I look at it, I don't see that. I see it come down off the pin, go into the one coil, come out the other side, and go to a tube pin. So I'm not reading this right. So it comes down here, goes this way. Yeah. Travels on a wire over to here, come back to the other. No, don't come back. Come off that, and shouldn't there be a 1000 on there? What is that? Great big piece of wire sticking out of there. Somebody didn't trim their wires when they did this. No, that's like a big tab or something in the middle. That'd be the capacitor right there. Right down there. And there's supposed to be 1000 coming right off there too. I think I'm tapping on this. I can see this capacitor going to ground. There should be another wire coming off. At least another wire. I don't see anything coming off there. Okay, so that's that terminal should have a capacitor on it. There it is there. Oh, no, what am I saying? You have to go on the other. Wake up. Hold on, let's go back. Back up. Look what's going on. Here to here. Through the coil, from here down to there. Through the coil up to here. Then, from here, it's going to this tube. Here's the 1000 right here, and there's another capacitor. Where's that going? It also goes to ground. So it looks like, what am I seeing there? 2 capacitors? I thought there was only one. So I would. That other capacitor has nothing to do with that circuit. I'm just seeing things. That's all it is, yeah. Okay, so this is the capacitor I need to worry about. This guy right here. And might be bad. Although I've done a test that suggests it's not. So we'll do another test. And we will see. Yeah, so I read, you know, I'm reading 100 and something ohms. I got this. It's pretty easy to change that. What are those? Ten thousand micro 10 nano 0.01 micro. Why would they show that as micro? It's pretty small. And I don't have a lot of small capacitors. I'm not convinced at all there's anything wrong with it either. Pull this resistor easily off of here, and test that capacitor. Let's try that. I don't know what else to do right now, so we'll try that. I feel like I'm shooting in the dark, but come off. Come on, you can come off there easy, can't you? Huh. Not so easy. Oh my gosh. Huh. Okay. Nothing like dropping little pieces of metal into your radio. That's off now. Now I'm pretty sure if I remember right, there's nothing to ground on this circuit except this capacitor. Everything else is just air. There we go. And this terminal that's, you know, that's 150K, so we're not looking at any kind of short circuit deal happening there either. I think I'm barking up the wrong tree here because I already did that test that more or less suggested these circuits did not have shorts on them. So continuing to look for shorts doesn't make a lot of sense. Unless I'm just doubting myself. Double checking is good. Maybe there's nothing wrong with it. I'm just chicken to operate it under the way it's been designed. You know, there's a very real possibility of that. So I'm going to stop for a minute, or a little longer. Let all this stew in my head for a while while I think of my next move, which I think is going to be operating and testing the radio more thoroughly. And we'll see where it takes us. See you soon.